Hi there. Thank you for the introduction. I'm like you said, my name is Lincoln. I work at a company called Animoto over down yonder on Lafayette Street, and we do video. We create videos out of like user content and whatnot. But I'm not going to talk about any of that. I'm going to talk about ServiceWorker, which is a web technology, a browser technology, and some sort of experiments we were kind of doing with it, building dev tools actually. So feel free to ask questions. If I'm in the middle of a thought, I might ignore you for a little bit, but I'll try to remember to get back to you. But just bug me if you got a burning desire to ask a question. And yeah, we'll talk about stuff at the end because, yeah, like I said, this is a sort of a big experiment that we were doing. So interested in all your opinions. And I should also say, I also have another slide dedicated solely to this point. Although this is a browser kind of based technology, I am not like a front-end engineer at all. So I do I do like platform, like API development and like back-end kind of stuff. That's kind of where my bulk of my experience is in. So, I'll show some snippets of code and whatnot, and, we're running this stuff, it's doing things, but just be gentle, Okay, so let's see here. So let's set the scene a little bit. A while back we decided we need to get a little bit more serious about understanding what our users are doing and tracking and analyzing, how people are using features and, funnels that are sort of functional rather than like just page-based and things like that. And we had some limitations with like GA for this. If any of you have tried to use GA for that kind of thing, you kind of run into some problems. Or at least if you don't pay a lot of money, which we don't. So we kind of put together using some software collectively sort of called Snowplow to kind of build ourselves a richer version of GA and that we could run in-house. And this is all just context for what we'll get to, but it's important to understand how it works. Basically, the way that we track, user activity, user engages in a feature or something like that. So, we do your normal thing, hit some sort of tracking pixel with a bunch of gobbledygook in the query string that tells us about what they did. So from the browser, we do a get. We actually have a little elastic beanstalk cluster in AWS. Everything we do is in AWS. At this one point, by the way, this was just CloudFront, so there's nothing that needs this to be like an actual thing that we run. Every once in a while, logs get rotated from that into S3. We have a periodic sort of ETL process where we read out all those logs, parse them, enrich them with other data, make these nice structured events that we then dump into some store that we're going to use for analytics. So sometimes that's Redshift. We're experimenting with other stuff as well. And part of that process, that ETL process, is we have this schema service. All our events are schema'd, right? We have every event sort of says, hey, I am structured in this way, and the ETL process parses the event according to the declared schema, pulls the schema from our sort of schema repository, and if they don't match, it throws it into some, a bad rows output that we can look at. And that keeps our event data clean so that during analysis, we don't have to have all sorts of special case rules to like deal with the garbage data that got in there. And that's actually been very, very nice. Although there is a little bit of overhead in terms of managing the schema and the evolution of those schemas. But if you've worked with like versioned APIs and things like that, it's not so different. So this is cool. This has a lot of advantages. A lot of these components are very, very standard, right? They're just like a web server that's logging request lines, basically. And we're using all the sort of normal features of various AWS tools, so they're very, very generic. The only part that we really have custom stuff on here is the ETL stuff, where we actually want to do our analysis, and our schemas are obviously ours. So this is really nice. We're not an analytics company. We're not a data where our job isn't to produce data. We want to produce videos and make good user experiences around creating videos. So for us, it's a priority to make all the other stuff as cheap and easy and simple as possible, right? We don't want to invest effort where we don't have to. So this is a good solution for that. It's quite simple. The downside, though, is that there's a really long feedback cycle, and it's a feedback cycle that we don't necessarily control. So if you see it back here, we rely on this sort of log rotation thing. Logs get rotated into S3 sort of whenever Amazon feels like it. And we could do some work, maybe control that a little better. We could invest a lot in making some sort of streaming thing, whatever. But again, real-time data isn't really a constraint for us, and it's just a lot more effort to do that. So if we could just solve this problem where a developer's great, I've got a new feature, I want to instrument it with some snowplow kind of events. Great, so I've got that there. I think I've got it all set up. I think my schema is right. I think my JavaScript is populating the event right and firing it. Now I'm going to click that button. Let's see if it worked. Okay, now I've got to wait hours before I see it go through the ETL pipeline, show up somewhere where I can actually tell if it worked or not. And we've tried to make it easier by, before this, we'd allow, all the bad data would get indexed in Elasticsearch, so you could see if you had bad data, and it was easier than searching through logs and things like that. But it kind of sucked. All the other aspects of the system were great. We really liked them. Just this one thing about development, the development cycle was painful. So we wanted to make that feedback cycle a little bit faster. So our goal here was to build a tool that gave fast feedback for developers, working in their browser, doing stuff sort of interactively, and also to break builds. If we run our sort of automated tests, using Selenium or whatever, it's clicking buttons around or whatever, we'd like to get to the end of that sort of cycle of runs and have the build break if we submitted an event that was not well structured. So here's some things that we wanted. Again, we wanted to be able to be used interactively or in an automated setting. It should be easy to adopt, right? We're trying to build a tool that engineers are going to be comfortable using. It's not a massive change to their workflow. It's got to live in the tools and be exposed in the tools that they're already using. So in this case, it's the browser. We'd like to not fork other people's code, right? If we have a third-party library, we'd like to not have to fork that code so that we can inject our own stuff into the middle of that. Now we've taken on an extra maintenance burden to make sure that we're always reconciling with them unless we can get them to accept that change or whatever. That kind of sucks. And we'd like to also not add too much operational overhead. So there might be some solution where we could, again, if we owned all the services involved, we might be able to, make the validating proxy or something like that. But now we've got an extra piece that we have to operate and make sure that that's up and that's working for all the devs in their environments, and it just adds a little bit of complexity. Possible, not sure it's not clear that it was the way to go. And also, as somebody who's trying to always, my role at Animoto is trying to look at, new tech that we can potentially use for other things. Dev tools are really exciting because you can build a dev tool that people use every day. It's a great situation to try out something a little bit new, see where it works well, where it doesn't, but it's a safe environment. You're not in production necessarily, where you have to sort of build a full thing that works, and it's the first time you're sort of taking it out for a test drive. So this was a nice opportunity to try something new. And that's kind of how I came to ServiceWorker. So if you're not familiar, ServiceWorker is a relatively new suite of browser APIs. Now, there have been flavors of this around for a while, and I think the current working draft is about not even a year old. There's browser support in like Chrome and Firefox. Safari is like sort of non-committal about its plans, that kind of stuff, about what you expect. Now, its sort of stated goal is to, and this is actually sort of my synthesis of it, but it's sort of like progressive enhancement for web apps to allow sort of native-like capabilities. So think that, a lot of times the motivating example are like, hey, this is going to work offline, or wouldn't it be great if browser-based apps could get like push notifications, things like that. And there's APIs in there to allow you to do that stuff. It does this by, there's a suite of APIs to give you sort of fine-grained control over access to resources, network resources, things like that. And then the other thing is it sort of gives you a background worker and an execution context that's independent of your actual pages. So a service worker, if you're familiar with web workers, it actually is a web worker, but its lifetime is totally divorced from a page. So you can close your page, and it will just keep going. It's doing its thing back there, and it's also this sort of progressive enhancement part. Like it's also that you're running a service worker is invisible to your application unless you sort of explicitly do things that would expect it to be there. And you get things like local storage. You can use IndexedDB and stuff like that. And then there's these two APIs that are really exciting to me because I put them in bold and have exclamation points. There's this fetch and cache API, which are just super cool. Like the fetch API, what it does allows you to attach basically everything's async in your service worker. And I'll show some examples, by the way. But you start up your service worker, and it's running back there. In that startup, or at some point in your service worker's lifetime, you can say, hey, I'm interested in when the browser is trying to fetch something from the network. And with some very minor caveats, just basically on how you instantiate the worker, you can now intercept any call to the network in an event handler in that service worker. Not just to your host, not to anywhere. Which, if you just sort of think about that for a while, there's some pretty crazy stuff you could do with that. So you can do fetch. You can intercept requests and respond to those requests in the service worker. You don't have to propagate that request out to the network if you don't want to. And that sort of brings us to the cache API. You can write stuff into this cache. You can read stuff out. You can, when you get a fetch, read out of the cache and return that stuff instead of going to the network, right? So that's sort of what gives you these sort of offline capabilities. But they give you a lot more capabilities too. And I guess when I learned about the fetch API, and I was kind of mulling over how are we going to do this event validation stuff, I thought, well, that might be a good way to try that out because I get these events, they're network requests. I have to unpack that request, and then I need to do some work and then sort of respond. And I thought it would be a good way to try that out. So again, massive caveat, I'm not a front-end engineer. So yeah, but I will say we are using this sort of in production rather. It's, in that our developers are, this is turned on for developers in their local dev environments, and we have it running on our integration build server QA stuff. So it works. It's cool. But yeah. I'll just say wrong things about the browser, and you just correct me or smile knowingly, and whatever. Okay, so let's just talk about brass tacks, how this thing actually kind of works. The service workers kind of happens in two parts. You'll register a worker, so you have a little snippet of code that says okay, I'd like to register this worker. And you give a little path to the script that is going to be that worker. And then the browser will go and load that script, parse it, and run it, start up an execution context just for that thing. And you get these little registration events both on the controlling page side and in the ServiceWorker that allow you to sort of do setup tasks like, hey, this is what I need to do when I first install the worker, or when when it becomes active on when you like load up a page or something like that, do these things. So that's you can do all sorts of stuff like that. And then like web workers, which are sort of in the lineage for service workers, you communicate with them, should you want to, using post message. So you can post a message to your worker, and your worker can post it back, and you can just subscribe to those message events. So, in some cases, like it could fail, and then you say, oh, everything sucks, and whatever. So there's a bunch of boilerplate around this stuff. For us, we just made like a little, we sort of try, we made it like a sort of client-server kind of situation where I have like a ServiceWorker client, and there's a ServiceWorker back there, and then it just has a lot of helper functions for like registering things and doing configuration and stuff like that. So for me, I said, okay, well, I'm going to register this worker client. I'm going to set up some event handling. And just as an example, hey, I'm going to pass in some configuration. I didn't want to bake in the config in our build process to the worker. We could have done that. I didn't really like that model, so rather I have the app who's using this library just pass it in. It sort of like puts a little constraints on my worker that it has to be sort of async configurable, like has to be able to start up without configuration and then get configuration later. But here, this set collection host is just a wrapper around post message, structure a little message to the service worker and say, hey, here's some config data. So in this example, it's like, hey, wherever my event collection service is, I can pass in the like host name, for that. Okay, yeah. And then I also had my client also like sort of gets post messages from the worker, and depending on what they are, sometimes I'll raise another event so that like a developer can subscribe to those events and do something with them if they want. So if something succeeds or fails in the validation process, I can have them respond appropriately. Maybe they want to add some hooks in like an integration or like a Selenium test or something like that. I don't know. So little sidebar, I just want to talk about what our events actually look like because it's helpful context for what we'll do next. So we have, this is like a basic sort of feature usage event. So we've got, hey, this is a feature usage event. We're describing it using JSON schema, and the version number of this schema is 100. It's loosely semantic versioning kind of style. And here's some stuff in the event, right? And and I'll say like I'm not showing a schema, but it basically says, okay, you're allowed to have say a field called scope, and in this case, it's an enumerated field where scope can be one of several items, right? And if it's not one of those, then it doesn't pass validation. It doesn't conform to the schema. And you can make it's quite rich in terms of what you can declare with the JSON schema. So in addition to the main body of our events, you can also pass sort of just an array of contexts, which are like, well, if I'm using a feature in our application, right? Probably there's a logged in user. So I'm going to pass a user context with that. So any action, any event that gets fired where there's a user present, we're going to include a user context. Or if it's with respect to a particular project, we're going to include contextual information about that project. And that helps us because it allows us to sort of not deduplicate, like every event has to have a project ID and every event has to have like a user ID or something like that. So it just kind of allows us to separate those things a little bit as well, which is helpful. Could
you give me a sense as to the volume of these events?
Yeah, we're not super high volume. I mean, I'm blanking on the like actual like total ingress amounts right now. It's not huge because we're not a huge high traffic company. But I would say like in the last few months we get a few billion things. So we have page pings, page views, actual feature usage, clicking around. That's mobile and web. It's not a trivial amount of data, but it's not like.
So if I were a user using your application, I would be generating, I don't know, if I'm actively using your application,
Yeah.
5-10 events a minute?
Yeah, probably something like that. Yeah, outside of so there's the page view stuff. There's like the sort of Google Analytics style stuff where it's like if you hit a page and then it's sort of doing a ping every once in a while to track how long you are on that page. So, that's sort of configurable what you want your ping interval to be. So it sort of depends on that. And then, if you're clicking around different features, just how fast can you use the app, I'll show you a little bit in the browser. You'll get a sense of what I'm talking about. These are what the contexts look like, by the way. They're pretty simple. Something about the user and what plan they're on and stuff like that, just to help you could get this by joining to other sources like our users table or something like that, but it's nice to sort of denormalize them because those change over time too, and just makes it a little easier. Okay, but our goal is we're going to submit stuff like this, and our goal is to validate that it is right, so that we don't ship the app with submitting garbage data, which is just annoying, and then you have to go back and ship it again, and I don't know. It causes a pain for us and for analysts and stuff. Even though we don't stick that into the main sort of events table if it's garbage, it's just we don't like to have gaps where we ship something and now we have a gap in data because they were bad rows. It sucks. All right, so I should just note that a ton of code is kind of elided here because it's just getting stuff working around. So I'm just going to show the parts that I think are the coolest parts about ServiceWorker for this purpose. But there's other stuff, and all this code is available on GitHub, which I don't have a link to in here, but I will somehow get that link up somewhere. Okay, so. And again, so some of it, because I just sort of paraphrasing some of this, it's not all going to be super, you're not going to be able to drop this in and run it. Just, okay, so this is within the ServiceWorker. You can just say, okay, I'd like to, subscribe to fetch events. And then for us, when we fetch, we're going to call this validate request method, and then we're also going to propagate that request onto the network. So we're just going to transparently do some stuff with it and not going to worry about anything else. And the interesting thing is that this is going to handle all my requests for images, for CSS, for everything, right? So if you're writing a tool like this, you kind of got to bear that in mind. But it's also really cool if you've ever wanted to breakpoint an image load. Now you can do that. It's kind of cool. So here we do just hey, we'd like to, if this is one of the collectors, if this request is to one of our event collectors, then we're going to run this validate snowplow request. And the validate snowplow request is going to unpack the event from the query string, which is just basically a bunch of base64 encoded data. And then we're going to traverse that structure, which is JSON, looking for schema declarations. And then we're going to validate each layer we're basically going to unwrap it. And as we're traversing through it, say, okay, here's a schema declaration. Let's go grab that schema from our schema repository. Let's validate the structure, right? Does it pass that? Does it validate against that schema? If so, great. We'll go look farther, deeper in the structure. Are there further schema declarations that we need to apply, or validations that we need to apply? So that should show you that the fetch API, we intercept stuff and do whatever we want, right? And I got some ideas of some cool things we could do with that apart from this, but we'll talk about that later. And then I'll just show the other part, which is the cache API. Now this is sort of deep in the bowels of the system, but essentially you can, for us, what we're going to do is all our schema declarations are URLs. They come from, we can sort of dereference them and resolve them to our schema service, right? So it would really suck if every time I was, validating a request or validating an event, I had to go to the network, get that thing, pull it down. Not only could that be slow, but it could just fail, and then I wouldn't get validations, and that would be really bad. So we can use the cache API, and we have complete control over the cache and when it's invalidated. So since our schemas, they're not rapidly changing, it's like you cache it once, it's valid forever. That's just the way by virtue of us sticking to that versioning, that's the way it's gonna go down. So in our resolver, what we do is as we encounter a schema declaration, we resolve it by fetching it from the network and sticking it into the ServiceWorker cache. And there's a bunch of variables here. You just have to imagine what they mean. But basically, we can have a bunch of named caches. We're going to have one that's our schema cache. And the cache API for doing requests is super nice. You just say like, hey, put this in the cache, and it will propagate it to the network if it doesn't already have it in the cache. Now, the interesting thing is this is not a resource that the user requested, right? This is a resource that's sort of embedded in their request, but nothing that they directly requested. So we're actually creating new requests based on what the user actually requested, or what the user agent actually requested. Again, sort of hinting at what I think are some really interesting uses of ServiceWorker. But this is great, and in practice, it's like it becomes like super fast. You cache it once, and then it's like instantaneous from then on. Let's see. Okay, so let me show you how this works in practice. So I've got my console open here as if I'm actually a web developer. And you can actually see already, here's my app. Oh, I'm sorry?
Can you zoom in a little bit?
Yes. Yay. That a little better?
Yeah, that's great.
So I just have it logging some objects here, but I'll close this off. I actually tweaked our app a little bit so that it will randomly fail when I use this feature usage event. So I'm gonna go in and use this feature, which is my title card editing ability. Hi there. Hey, look at that. Nope, it didn't fail. Okay, sorry about the excess logging. But it said it was successful. So that's actually kind of cool. I can just look in there. This is just a log thing. It tells me, these are actually two contexts, the user context that we saw before, and there's actually a project context in there. And then let's see if we can get it to fail. Please break. – 50% of the time, Oh, there we go. So I actually have it by default in sort of dev mode, raising errors, because we already break builds based on the presence of JavaScript errors. So this was an easy way to do that. But I'll also subscribe to this event here that shows me the failure. Just says data.scope must be one of the enum values. And I can just go and actually look at the schema for that and the thing. So, oh, my scope is stupid instead of one of the allowed values. So right now I've got immediate feedback that my event, however I'm constructing those events, is wrong. And I'm doing that using the exact same schemas that I'm using in the ATL pipeline, because they pull from the same repository. So it's quite nice. And we didn't have to run any extra infrastructure. We are doing this right in the browser, so we have complete control over how it works, and it's completely transparent to the application. Like, you just never would even have to know. If you didn't know that there was a service worker here, you would just think something in the browser is just like creating these events, making these errors happen, right? And we've gotten really good feedback from the engineers who have been using this that it's streamlined their workflow on this stuff. But just wrapping up the sort of presentation part, we talked more questions and discussion. I think this is really cool. Like, what this really showed me is that this like ServiceWorker stuff, I think the like offline app stuff and whatever, I think is like, I mean, that's cool, that's fine. But I actually think that there are so many more interesting, as like a back-end person, I'm thinking about this as like, I'm pushing the network and like my service tier into the browser. So now I can think about like, what are the things I can do at like a service level that now I can like push to the client? And I can maybe do that without the client even necessarily knowing about it. So if I have a capable user agent, well, I could, like maybe I change request to my image resizing service to just happen in ServiceWorker. And then all of a sudden, I don't have this load on my service. Network latency is perhaps much reduced, depends on how you do it, I guess. Or like, let's say I have a big like manifest of metadata, right? Changes every once in a while. Well, imagine I could deploy that using some sort of MD5 kind of situation, right? And then when I get a request for that in my ServiceWorker, I could propagate the request, using like the hash of that thing that they're requesting to the service, and the service could reply with just a diff, and I can apply that diff to what's in my cache, right? So now I've just like synthesized a request, but my actual network traffic is like much lighter, right? So you could do all sorts of crazy stuff like that, and it's really nothing to do with like offline or whatever. It's like just pushing this like extra work, this extra intelligence into your browser, and I just think that's like, I think that that's really the cool part, and I guess that's what I got most out of this project is like, yeah, we solved a real dev problem that we had, but the other aim of like, well, let's explore something that we think we might be able to really use, and especially for people who are doing lots of media manipulation and stuff like that, it's really thought-provoking. So yeah, that's how we built that and why. Let's have some questions, because I'm sure there's lots in here that is weird.
I'm fairly ignorant about ServiceWorker, so enlighten me a little bit. As I understand what you're doing, you're intercepting effects, so the ServiceWorker is synchronous with respect to the UI. No,
everything's async. Everything's async. So you'll get somehow the fetch event gets sort of raised in the ServiceWorker. You catch that, and if you propagate that thing, it returns a promise, and you just sort of return that back. So yeah, it's just like it's all async, right? Like you don't like from the controlling page, it looks like a normal request, but the parts in the ServiceWorker are all async. I guess is that what you mean?
That's what I was trying to.
Yeah. So the browser, nothing changes from like if you're writing just like normal like browser stuff, everything looks the same. Like you do not know that it's there. In the ServiceWorker, it's everything. Every operation is async. Everything's like all promise based, all that stuff.
How do you your app loads? You have to instantiate the ServiceWorker. So I mean, it's just a script tag, an extra script tag in your.
Yeah. So the way, let's see if I can show you. So like, where is it? I've got a partial in here somewhere. Yeah, so at some we featureize stuff. So in our case, like it's like if the feature is turned on, then we're just going to embed these script tags. One of those script tags is the client thing. And we didn't do like the sort of packing this all up into like a one thing because again, dev tool didn't care so much about that.
So you're loading the snowplow library, and it's just a matter of which one.
Yeah, so like
worker and one of them done.
Right. So the client is just like the the library that will do all the boilerplate registration stuff like that, and then we have this init snowplow thing, which actually uses that library and does the actual registration. And the registration process is Yeah, this is the sort of raw kind of registration, and that happens in the sort of init side, and then the actual worker code is completely separate. So it's like it feels almost like, other than the sort of promise aspect of it, it's almost just like free floating stuff. You don't ever talk about the window. You don't ever talk about.
It's a server running in your browser.
Yeah, I mean, I was going to say it feels a little bit more node-like in a way, because you don't really use browser DOM. There's no DOM. You don't have access to the DOM. Like, yeah.
That's cool. So I guess that's what's going on when your browser pops up and it says this page is trying to load something that will run even after you close the tab.
Yeah. So I don't have it here, but like Chrome now has a thing that every once in a while pops up here. It's like, hey, this thing wants to register or install a background thing, and you can authorize it to do so.
So that, I think, answers my question, which was, what prevents you from installing a Bitcoin miner?
Yeah, I mean, I think it's just up to you to like grant that permission. Yeah, I mean, it's some really interesting stuff, but I guess there are some security things right there. It has to be loaded. Everything's over HTTPS, so if you're doing this if you're building this like locally, you just got to make sure you've got everything set up so that'll work. There's restrictions on what the service worker what it can do in terms of what it can access, and so there's a bunch of cores related stuff kind of related to that. So there are some things in mind there, and the spec says that the user agent is allowed to shut down the thing if it surpasses certain limitations which are unspecified. So if you're spawning a bajillion web workers or something like that, maybe it's going to get mad at you and shut it down. I haven't really run into that yet, so I can't really speak to what happens there.
Have you stepped through the debugger in the browser? Because I was kind of curious if I pulled up DevTools and I wanted to step through this code.
Yeah. So let me show you. The way you'll do that is you'll go to resources. Where is it? And there's the thing, ServiceWorkers here. Now, it'll show you some of the errors that we had. This was actually, my page was pinging away, and my like local stack was offline, or I think I was had no internet connection or something. But you can go ahead and inspect that, and you've basically got this whole other context here. Your own console, right? I can look at my code here and then set breakpoints there as well. But it's relatively new. Not many people seem to be doing a lot of stuff with it. So the tooling isn't great. There's some wonky stuff. Like you have to kind of have to fiddle with it a little bit to get it to do what you want. Like it's interesting, if you make changes to your script, it'll restart. But if you use if you load scripts from within your worker, well, changing those won't cause the server or the worker to refresh, and all those things are cached, and it's hard to figure out where they're cached. So that can cause some problems. So if you're going to do this, I would suggest doing something where you just actually build do like Browserify or whatever, and like get everything built into one thing. That way, if it changes at all, the browser will actually properly reload it. But yeah, I had a lot of trouble just fiddling with the tools. It wasn't immediately obvious how it all should work. Do you have a question?
Have you guys used IndexedDB much within larger file sizes in ServiceWorkers?
No, and I'd originally thought I was going to be using IndexedDB to do my caching, because I was just like, well, these aren't requests necessarily, they're like schemas. But then I was just like, well, I don't care. Like, so what? I'll get the request back and then just like pull the body out of the request from the cache. That's fine. So I thought I was going to do that, but I didn't. So I can't really.
We've run into some wonky things at Ritter. We do the MD5 file comparisons.
Oh, okay.
But I've been playing around with doing some of the video transcript process, running a
Sure.
leg in there.
Yeah.
And IndexedDB kind of tends to be like, I don't know, I think it's based on the actual computer and like they don't give you hard limits on file size.
Yeah.
I'm curious if you guys are.
No, I mean, those kind of things are something I think would be interesting to like work on, and we have some ideas for how we can use it for our video rendering process, but we just haven't gone there yet. But
It's definitely still kind of sort of.
yeah, it's like the frontier. It's like it's kind of weird.
I ran into something yesterday where Chrome at least has some sort of formula they use based on the amount of free space, and I think they were willing to give a page up to a fifth of that.
Yeah,
And if it runs out, it just wipes out the whole count.
it's supposed to be based on the available file size of the computer, and like we've gotten sometimes where like it's been kosher into gigabytes, and then sometimes like limits you to, I don't know. I'm trying to figure out.
And it doesn't correlate with free space on the disk.
It's supposed to, but I don't know.
That's my next.
Yeah.
Your experience is it doesn't.
We haven't had it, not consistently yet, at least. Maybe that's because it's experimental, but I was curious if you guys had figured that out as well.
Thankfully, no.
Cool.
But I also don't know. I haven't dug into like if you just were like to throw a bunch of crap in the like cache. I actually don't know what would happen. I don't know what the life cycle of that cache is if you're sort of abusing it. So that's something.
Capacity to be abused, like you could.
Yeah, right. I was like, well, okay, could you like fake a request and throw it in the cache? I don't know. Other questions or comments? Cool. All right, thanks.